Hey guys, tonight we're going to talk about absolute value. And most of you have done some things like this, but I'm kind of worried that you may not have done absolute value inequalities. So how far away from zero are the following, -4 and 4? Well, hopefully you know that they're both 4 away. And so both the absolute value 4 and -4 are 4 units away from zero. So let's start with something as simple as this. Hopefully this is something that's not new to you. There are two places, and we're going to pretend that this doesn't exist. There are two places that are 30 away from zero, correct? There's one that is positive 30, and there's one that is negative 30. Now, once that you have that information done, you're ready to play. Go ahead and set up the two equations. And -6x is equal to 30, and the other one is -6x would be equal to -30. Divide both sides by -6, and you'll find that the one thing that will make this true is x is equal to -5. But the other thing that will make this true is x is equal to +5. So there are two answers for this absolute value problem to be true. Let's try it again. This time notice though that 7 is the coefficient of the absolute value. So before we look for the absolute value and make it into two separate equations, we need to divide both sides by 7. And what you will find is the absolute value of some number is 8. Oh, I know this one, Mrs. Rose. There are two places that are 8 units away from zero. The first one is +8, and the second one is -8. Notice this has a coefficient, if we think about it, of 1/5. Multiply both sides by 5, and you'll want to know that the absolute value of m is a distance away from zero of 15. Mrs. Rose, I know the answer to this one as well. 15 and also -15 are 15 units away from zero. Now, what if you have a constant? Well, this is easy. Isolate the constants by using additive inverses, and the absolute value of m is equal to 9. Mrs. Rose, there's two places away from zero that are 9 units away. One of them is +9 and one of them is -9. Very good. Now, let's see if you can do this one. Add 8 to both sides, and you get the absolute value of x divided by 7 is equal, that should be a straight line, is equal to 1. Okay, now not so fast, my friends, because this 7 is not a coefficient. This actually divide by 7 is part of the absolute value. So you do have to set up two equations. X divided by 7 is equal to 1, but another place that it is there is also -1. Multiply both sides by 7, and you'll find that x is equal to 7. Multiply both sides by 7, and you will find that x is equal to -7. If you substitute these values in for absolute value, you will find that both are correct. Okay, what about this one? Go ahead and write it down and see if you can do the work. Be prepared for class tomorrow. So, what do you remember about compound inequalities? And we talked a little bit about this with one of my class periods. If it is an or, then you know that you have to treat them separately. X plus 6 greater than or equal to 11, subtract 5, subtract 5. X has to be greater than or equal to 6. But x plus 3 less than or equal to -2. Subtract 3, subtract 3. X has to be less than or equal to -5. So, greater than or equal to 6, close dot, going this way. Close dot on the -5, going this way. This is an and, though. In the case of an and, you have to treat both sides exactly the same. Okay, so case in point, b plus 5 is greater than or equal to 5 and less than 9. To isolate the b, you have to subtract 5, which means all parts have to remove the quantity of 5. This would be 0 is less than or equal to b less than 4. The way that we correctly read that is b is a quantity that is greater than or equal to 0, so greater than or equal to 0, but less than 4. There's the 4. And all of the quantities within these 2 points, inclusively with 0 and non-inclusively with 4, are the correct answers. So how do these relate to absolute value inequalities? And I would like you to do a card for this. Absolute value of inequalities. If the absolute value is less than a, when a is greater than 0, you ask what values of x have an absolute value less than a. The solutions are numbers between negative a and a. The properties are true for inequalities that use the symbol less than or equal to. Okay, now, here's my hint. I like to think of this as the great Tor dilemma. The absolute value of 5p, negative 5p, is greater than 20. Okay, well, let's think about this. That means that this can be two values, correct? One of them can be 20, and one of them can be negative 20. Okay, we write the original down, put the great Tor, but since you have made this the inverse, you will now make this the inverse. Divide this by negative 5, divide this by negative 5. Oh, wait, p becomes less than negative 4. Divide this by negative 5, divide this by negative 5. Oh, wait a minute, p becomes greater than 4. Negative 4, open dot, arrow left, open dot, arrow right. Can you figure out why Mrs. Rose has called this greater? Have you figured that out yet? Well, let's see. Let's do the other one. You go ahead and set it up and see what you think is correct, and I'll see if I get the same answer as you do. All right, I have a positive 3, I have a negative 3. I have x minus 3 is greater than 3. I have an x minus 3 is less than negative 3. Add 3, x is greater than 6. Add 3, x is less than 0. Greater than 6, arrow goes right. Less than 0, arrow goes left. Oh, wait a minute, Mrs. Rose. I know why you said greater. Because when it was an or value, they did not meet. Oh, maybe that's why Miss Rose calls this less than. Now, I know, silly Mrs. Rose, that does say less than, but let's see what she means by less than. Well, 1 plus x is less than 8. 1 plus x greater than negative 8. Subtract 1, subtract 1. X is less than 7. Subtract 1, subtract 1. X is greater than negative 9. Greater than 9 heads this way. Less than 7 heads this way. Oh, wait, look. Oh, wait a minute, Mrs. Rose. Take a look. What happened with and? Oh, they met in the middle. And meets in the middle. Oh, Mrs. Rose. Less than meets in the middle. Well, let me see. Let me just make sure I'm right. 7x less than or equal to 42. 7x greater than or equal to negative 42. Divide by 7, divide by 7. X is less than or equal to 6. Divide by 7, divide by 7. X is greater than or equal to negative 6. Close dot, arrow going this way. Close dot. Oh, look at Mrs. Rose, you were right. Look how smart you are. Oops, made a mistake there. Got to be careful when you do this, guys. Make sure that I can read where your stuff is. All right, so someone made a mistake, and I know this one is kind of hard to read, but what mistake did they make? They subtracted 3 from both sides. That's correct. But then look what they did. There's a mistake here. Can you figure it out and let us know by tomorrow? I hope so. So, what equation can represent all points exactly 2 units from 3? Let's see now. Here's a number line. And here's 3. 2 units away from 3. 1, 2. That's 5. 1, 2. That's 1. Those are the 2 points that are exactly 2 away from 3. Well, let's figure this out, shall we? 1 plus 2 equals 3. 5 minus 2 equals 3. Can you figure it out? I hope you can, because this is where we go tomorrow. What about this one? All points within 5 units from 6. 6, 11, 1. All the points within 5 units. Can you figure out how to write that one out? I hope so, because that's where we're going tomorrow. What about this? The depth D of an aquarium tank from dolphins satisfies the absolute value D minus 50 has to be less than 5. Rewrite this as a compound inequality that does not involve the absolute value function. Miss Rose. Less than. Well, here's 50, and it has to be less than 5. So it can go up to 55, but not include it, and it can go down to 45, but not include it. What can the depth be? It can be less than or equal to 55. Oops, not or equal to, Mrs. Rose. It said up to that point. You need to remember that tomorrow when you're doing this. Don't make the same mistake Mrs. Rose just did. And greater than 45. Oh, I'll bet that this right here might help me with those 2 problems there. A bed must be within 1 foot of 9 feet. Okay, here's 9. Here's 10. Here's 8. Oh, the bed has to be less than 10, greater than 8. Can you look at this problem and see if you can write the absolute value inequality? Here's 2 websites that might be able to help you out before we start tomorrow. Go ahead and pause, but then see if you can work this problem and be ready for tomorrow. Toodles! See you tomorrow.